In this associate level introduction, which should set you up nicely for all associate level network qualifications including Cisco's CCNA 201 to 301, Huawei's HCIA routing and switching, the Juniper JNCIA, and the Nokia/Alcatel-Lucent NRS1, we will be loosely following the official CCNA coursebook material as it is the most in-depth, but we will also be sprinkling in vendor-specific terminology, and for that we will be using Alcatel-Lucent's Scalable IP Network Self-Study Guide for the NRS1 and also the HCIA Study Guide. The first thing that we'll start off looking at is what is a network. All you need to know at a base level is that the purpose of a network is simply moving data from one device to another. However, a more official response, if we look at our all-knowing friend Google, is a group or system of interconnected people or things. This is a good starting statement, but probably ends up leaving us with more questions than answers. Let's start to break it down. First of all, we don't need the people as we are looking at a computer network, and we only need the group or the system. I will choose the group. That leaves us with a group of interconnected things. So what is this group? How and why are they interconnected? And what are these things? I will start off with this last question. What are these things? I'm going to join the two statements that I mentioned earlier and try to explain the concepts as we go along. So our new statement now reads: the computer network is a group of things interconnected for the purpose of moving data from one device to another. This one brief statement answers our questions: why are they interconnected? And sheds some light on the discussion of things. These things are devices. Let us explore a bit further. We have two users, the Bob on the right. Have you noticed that it's always Bob then as one of the PCs, and Lucy on the left? PC/endpoint, these two devices are endpoint devices, but as they are not interconnected, then we can't say that they form a network. But as soon as we connect a cable between them, then these two endpoints form a network. What is a network endpoint? There's Bob again. Endpoints are devices that allow users to access network resources such as applications, data, and services. This allows users to perform their work, communicate with each other using email, instant messaging, video conferencing, and other communication tools, and basically do their jobs. Examples of endpoints include desktop computers, laptops, smartphones, tablets, and also servers. Servers are network devices that are used to provide services to other devices on a network, such as file sharing, email, web hosting, database management, and application hosting, and are typically more powerful than endpoints, with more processing power, memory, and storage capacity. Servers can be physical or virtual, with virtual servers running on a virtualization platform. So, for example, if there was a file or application that more than one user needed to access, then they would connect to the file or application server to access it rather than it being stored locally on a user's endpoint device. Now this is great if there are only two devices on your network, but what happens if we add a third or maybe even a fourth device to the network? Each of these endpoints usually only has a single network interface card, NIC. And if Bob and Lucy wanted to communicate with Anderson and Jamila, then they would have to either add additional network cards to their device or disconnect the cable and reconnect again to the new endpoint they want to communicate with. Fortunately for us, there is another way, and that is to add a switch. Switches are network devices that are used to connect devices and networks together. Layer 2 switches operate at the data link layer of the OSI model and use the Media Access Control (MAC) addresses of devices to forward frames between devices. They support features such as VLANs, spanning tree, and link aggregation. Layer 3 switches operate at the network layer of the OSI model and use the IP addresses of devices to forward packets between different subnets and networks. When a data packet arrives at a Layer 3 switch, the switch looks up the destination IP address in its routing table and forwards the packet out of the appropriate interface. Layer 3 switches support features such as quality of service, QoS, virtual private networks, VPNs, and access control lists, ACLs. In summary, Layer 2 switches are used to connect devices within a LAN, which is a collection of devices connected together in one physical location, such as a building, office, or home, while Layer 3 switches or routers are used to route data packets between different networks. This also partially answers one of the questions that we had above, namely, so what is this group? Well, the answer is the collection of devices connected together in one physical location, which we call a LAN. As a recap, switches allow endpoints, PCs, phones, laptops, printers, to be interconnected so that they can share resources. Access points, APs, are networking devices that are typically connected to a wired network and use radio waves to communicate with and provide wireless network connectivity to wireless devices such as laptops, smartphones, and tablets. Roaming is probably the primary role of access points, which extends the reach of a wired network by providing wireless coverage in areas where wired connections are not feasible or practical, allowing wireless devices to maintain a connection to the network as they move between different access points. Routers are networking devices that operate at the network layer of the OSI model and are responsible for finding the best path to forward data packets from one network to another. Routers use routing tables which contain information about the various networks that the router is connected to so that the router can make decisions about the best path to take based on the destination IP address of the packet. Routers often connect to switches, and you need a router, or a Layer 3 switch, to be able to route between networks. So say you had a LAN in USA where your endpoints are connected and another LAN in India where your servers are, and you wanted to share information between them even though they are geographically dispersed and cover such a long distance, then we will use a router to route between these networks. Next-generation firewalls, NGFW, are security devices that are designed to protect computer networks from various cyber threats such as viruses and unauthorized access. A next-generation firewall, NGFW, combines traditional firewall features that only inspected traffic from layers 1 to 4 of the TCP/IP model with advanced security features that allows the next-gen firewall to perform deep packet inspection and analyze and identify traffic right up to the application layer. This allows NGFWs to block traffic based on the application, user, or content type, and these firewalls can sit inside your network, often between the router and the switch, or outside your network on the other side of the router. Now, it's question time. 1. Which of the following are defined as network endpoints? A. Laptop. B. PC. C. Server. D. Mobile phone. E. All of the above. The answer is E. All of the above devices can be considered computer network endpoints. 2. Complete the following sentence from the options below. A computer network is a group of things interconnected for the purpose of A. Communication. B. Playing games across a LAN. C. Moving data from one device to another. D. Movie streaming. The answer is C. Whilst all of the answers could be possible, C is the best definition. 3. If you wanted to send information between networks, which device is necessary? A. The router. B. The switch. C. A laptop. D. None of the above. The answer is A. 4. Which of the following services does a switch provide? Choose 2. A. File sharing. B. Text messaging. C. Wireless roaming. D. Forwards frames between devices. E. Forwards packets between devices. The answer is D. 5. Which layer of the OSI model do routers operate at? A. The application layer. B. The network layer. C. The data link layer. D. The transport layer. E. The physical layer. The answer is B.